Logistic regression classifier is based on the posterior probability of the evaluated class belonging to samples to the evaluated sample belonging to class C given the observed data. Now in this case, the posterior probability is modeled using the sigmoid function, which is defined mathematically by the equation that you can see in the slide. And then graphically, you can also see the sigmoid function to the right-hand side. And you can see that it's a smooth curve that goes between 0 and 1. And from the sigmoid equation, f of x will be defined as a linear combination of the different features in the data. So that we have beta 0 plus beta 1 plus times x1 plus beta 2 times x2, etc., etc. So let's assume now that we define the binary cross entropy, or that we use the binary cross entropy function for this binary classifier. And here the loss will be defined as you can see in the slide, where y, capital Y, is the desired output, so the targeted class, so either 0 or 1, and y hat is the predicted class, the predicted output. So our objective then is to minimize that loss function. And what we need to do actually is to find the values of the betas, of the parameters that minimize that function. We can't change the data, but we can change the parameters in the model. If we solve this, again, hypothetically, using the gradient descent, we could use other methods, but let's focus on the gradient descent. And we apply the gradient descent to the binary cross entropy loss, then this is what we get. That's the derivative of the loss, and then we can update the values of the parameters by the using the derivative. So what are the hyperparameters and the parameters of this classifier? Well, hyperparameters, none a priori. There is nothing that we need to set here before we see the data. And in terms of the parameters, it's the coefficients, the betas, that we need to find out using the training data. Logistic regression classifier is a very intuitive and straightforward concept. The models are easy to interpret and actually quite informative, because we can use the values of the coefficients to get a sense of the relationship between each of the features and the model output and the class. However, this classifier only models linear decision boundaries, and it's not robust against multicollinearity. So if we have features that are, again, correlated somehow, then this is going to affect the model. Perhaps not the model performance, but it's definitely going to affect that ability that we mentioned earlier about using the values of the coefficients to understand the strength of the relationship between each of the features and the outcome. And it's not suitable for high dimensional data, generally speaking.